also have some like, ooh.
All right, now we have this message and welcome. This is the second Y community call. Now we have Braden and Carlos. Braden is the author of LegendKeeper, a really cool app that he's going to talk about. Do you want to make a short introduction of yourself, Braden?
Yeah, absolutely. So my name's Braden. I'm a software developer and I guess startup founder based out of Texas in the United States. I actually started my career making dating apps at the world's largest dating company as a mostly mobile developer. And then one day I was getting into D&D and I was also like, I want to learn web development. And so I created a tool for myself to help me DM for my friends, right? Be a game master or dungeon master. And I was just using that for a while for myself. And then eventually I posted a GIF on Reddit. And a few hours later, my friend texted me. He's like, hey, is that your app on the front page of Reddit? And I like go to my phone and my phone is just like exploding. And it's getting all this attention. And so I'm like, oh, cool. People are like interested in something like this. And so over the next few months, I tried to get it to a place where it could be used by other people because the prototype I showed was all mostly smoke and mirrors, right? It was like the UI was talking directly to the database and like the JavaScript code in the browser was like making SQL queries and stuff. So it was definitely not like production ready. So I got it production ready and then released it and got a few customers and we've just been growing ever since.
That's so cool. Like, I didn't know that you weren't a web developer. So is this something you started in between your career?
Yeah, so in college, I got a degree in computer science, and in college I had a few like very small like web dev projects. But for the most part, my first job out of college was iOS development until for a couple years, and then I switched to Android development for a while. So I was mostly entirely mobile, and I really felt that web was just an area I didn't understand well, and I wanted to like really dig in. And so I started this, LegendKeeper as a side project. And of course now I'm, all in on web dev, right? I haven't done mobile in a couple years,
Right.
Or I guess a year or so.
And I think you financed this app using some crowdsourcing campaign, like Kickstarter or something.
Yeah, so it's a little unorthodox. We use Patreon to fund development. Which is great. We do want to get off of Patreon, but it has been incredibly helpful in kind of getting everything started, right? It kind of gives us this nice, scrappy community vibe, which is exactly what we are. And, provides a place where we can keep everyone updated and send out emails and, of course, collect funds for, running the app on a monthly basis.
Right. So what I find really interesting about this, right? You started web development, like came fresh into this to develop a tool that you want to use for your own GM purposes, right? And then it got popular, and now, like, I know your app, and now it's like one of the most supercharged note-taking apps that is probably out there. I mean, it's crazy cool what you built.
I'm.
Do you want to show maybe what this app is, what you built?
Yeah, absolutely. I've got a demo ready to share right now.
Awesome.
Let's see. So, can you see a cool fantasy map?
Yes.
Okay, awesome. So what LegendKeeper is you can think about it as a knowledge management app for game masters and storytellers. So people who are playing D&D or any other tabletop RPG generally have a campaign setting where their world takes place, right? And building a campaign setting is a really challenging task. There's a lot to it. You have to, know all the places in the world and you have characters and shops and spells and monsters, and there's just all sorts of stuff to manage. And I personally found it overwhelming. And so at first I was like, okay, surely there's software out there to solve this. And there was, but what I found was most of it was very old and hard to use. And so I was like, okay, I'm a developer. I want to learn web development. I want to make an easy to use, pretty app, right? And so this is LegendKeeper after I have a design co-founder, by the way, Justin. He's like a user experience and aesthetic genius, and so he's the one who's responsible for the pretty and functional part of it. I do a lot of like the coding and like product features and like that sort of thing. But we all do a little bit of everything. So here you can think of LegendKeeper as like Wikipedia plus Google Maps for a fictional place, right? And so here's my map of the Moonlight Cape, right? Just a location in my D&D campaign. And so you can place pins on the map, you can move them around, you can dive in and see like, okay, here's like an article, right? And see more about the article, or I can, since I'm the admin of this project, I can dive in and like start editing, right? And so type, whatever, right? And just really get into like the creative zone. So this is the Atlas view. This is how you reason about your world spatially. We also have a kind of a more traditional wiki view, which is the same thing, but kind of reasoning about your world from a traditional wiki perspective, where you can create articles, you've got page templates you can make. The editor, again, you can go right back to the map. Ooh, not loading. Anyways, little bug there. So yeah, that's kind of the core of it. Like it's intentionally pretty simple, because what I found was a lot of apps out there kind of, in my mind, really complicate the process, which is I think great if you like lots of guide rails when you're creating, right? Like a lot of apps like this out there will prompt you like, what's this character's name? What's their hair color? What happened in the year 20 whatever in your world? Who is the king? And I found myself being like, I don't know. I don't know the answers to the questions that you're asking me. And so I'm a big fan of Notion, right? And so if you use Notion, you can probably see a lot of influence here, where I kind of like the free form, canvas of text to be able to just like ideate and be creative.
Right.
And you've got like the asset manager to like manage your images and stuff.
Have you already this feature enabled where some people can see content and others can't?
Yes. So it's one of the interesting challenges of a GM, especially when it comes to wikis. Most wikis assume that you're going to be sharing a lot of stuff, right? But that's not a great assumption in a storytelling scenario, because some of the storyteller, the game master, probably has a lot of stuff that they slowly want to reveal. And so it's an interesting challenge in designing an application that kind of lets you work that way. For example, let's say I mark this, so you can just completely hide an article, right? And so you could, a GM could invite their players and come, and they wouldn't see, this, right? But they would see everything else. You can also do like more advanced permissions where you say like, oh, I want this person to be able to, edit, right? Or manage it or whatever, or they can't see it at all. Additionally, you can actually create blocks of content that are secret, where anything I put in this block, only admins can see it, right? Only the game master can see it. So this is a secret. So if someone else were to come along that was not an admin, they would just see, it was meant to curb hello YJS, right? And a blank spot there. Even if they can edit it, they still won't be able to see it. And the editor will kind of work around that hidden content, which is also an interesting challenge too.
Right.
In the future, what I want to be able to do is like, right click this or add a menu and say like, select who can see it, right? That would be very cool.
Oh, that would be interesting. Like for some people who have true sight or some other capability, who can see characters or information that others can't read, right?
Exactly.
Oh, that is pretty cool. I really like that idea. So something that always felt unnatural, as long as if you have like one people with true sight, they can just tell you what they can see, right? And
Yeah.
now this person needs to figure out themselves, what is it, what I can see, what others can't see, maybe.
Yeah, that's really cool. That's like very cool, like metagame stuff. And we
Yeah.
are seeing people start to do that, right? Like
Mhm.
we have a few folks that actually run entire what are called West Marches games out of their LegendKeeper project. And if you're not familiar,
Mhm.
a West Marches game is where it's like a bunch of different kind of self-organizing D&D groups. Maybe it's like 20 people or 100 people or whatever. And they, there's no single like game master, right? It's self-organizing games in like the same big setting. And so Legend Keeper serves as like the host of the setting, and then people come in, they run their their thing, they take notes, they drop pins on the map and say like, oh, this party was here and blah blah blah. And the next
Mhm.
person to come along can like build off of that, right? Or maybe they're on a completely different part of the map, which
Yeah.
is pretty cool.
Super awesome. So basically, you created a super, like a really complex note-taking app, or like, well, writing application with many features, right? With secrets, there are a lot of features.
Yeah.
Um, I know that you use Browse Mirror as an editor, probably your own creation, like your own plugin system there. And I know that you use YJS for this, which is why I asked you to come on this call, right?
Yeah.
And so basically, I met Braden because he and a friend of yours, I think from a different startup, funded the subdocuments feature of YJS.
Yeah.
And yeah, I was really grateful for that. And then I noticed what you are actually building, and what makes, at least from my perspective, your app super interesting is how you use YJS subdocuments and offline editing and the offline search functionality and all that stuff. You want to talk a bit about how you integrated YJS and what makes your application special?
Yeah, absolutely. And yeah, I totally forgot to show off the search. It was like
Right.
one of the coolest parts. So we do have search in our app. It's
Mm.
full text search and it's completely offline. The client actually manages their entire search index. And again,
Mhm.
this is something that kind of YJS enables us to do. And this was super exciting because as a creator, right, and someone who is, I'm in the tech industry, right? And like the idea of putting my entire D&D campaign, which, for a lot of people is like years and years of work. The idea of putting it on a web app is like a traditional web app is like, do I want to do this, right? Because, the server could go down, your internet could go out, the company could go out of business, they like sell all your data, whatever. Lots of stuff could go wrong when you entrust that stuff.
Mhm.
But doing that and trusting is also really like beneficial because you get stuff like it's available on any computer and it's on the internet and you can share it with your friends. And so for the longest time, I was looking for the middle ground, right? The compromise where the user retains control of their data and can use it whenever they want, right? But it's also online and they can share it and maybe even like publish their content or whatever, right? And so um, I stumbled upon YJS, and I don't exactly remember how exactly I found it, but I was following it probably for like a year before I built the first Legend Keeper prototype with YJS. And yeah, so my colleague from college, Izu, he's creating a like a low code like builder platform. I'll probably butcher his like elevator pitch, but he's creating a platform called Shiso using YJS. And we were both talking about how cool it was because I saw him he commented on a PR, and I'm like, oh, hey, that's my friend Izu. Like, what's up, dude? Like, how's YJS going? Um, and so yeah, and so we had a chat and we were like, oh, what we really want is the differential updates feature that like really unlocks our options. For those of you unfamiliar, um, the one of the main YJS API, right, involves manifesting a Y document in memory, right, that you then manipulate. Um, But coming from LegendKeeper, which at that point had already had, 20 or 30,000 users, a lot of which had moved their entire D&D content life into LegendKeeper. So just thousands upon thousands of documents. I knew right out of the gate, my first requirement was this needs to scale to a level that like prolific users can use. People who are just like, some folks get on LegendKeeper every day and they just churn out articles, which is amazing. Like, I love it. And so I don't know where I was going with that. Right. I knew that like holding all of those Y documents in memory, like in the working set, like would be tough. And so it was differential updates. The ability to essentially manipulate a Y doc without loading it into memory was super important. So we funded that. And then from there, I was able to build an architecture that kind of met my needs.
Yeah, so basically you told me how prolific your users are sometimes, like with thousands of documents per account,
Yeah.
which is crazy. And these are huge documents. And basically the problem you were facing is now I have like an offline app and I can already store the data offline using, for example, YIndexedDB, but that's only per document. And I can only synchronize per document. How can I synchronize thousands of documents that I have for offline usage with the server? So in case I want to synchronize the things that I created offline, and I want to synchronize the things that were created by other users that I want to sync downstream. And I think you built the first application that made that. Like I built the differential updates feature that is the foundation for that, because it allows you to efficiently synchronize a single document without loading it to memory, and also calculate like state vectors and all that other stuff. And like it's super efficient without using any memory at all, like except the binary content loaded to memory. How did you build the synchronization mechanism? Actually,
I think first, like the journey from deciding to use YJS to the implementate, like the architecture we have now was one of like multiple steps, right? And so I'll enumerate those steps because I think a lot of people are probably going to go through kind of the same journey as they like understand YJS, as they understand their needs better, as they understand their application better. At first, when I first started using, am I screen sharing? I am. When I first started using YJS, right, at first I said, okay, I will use a Y document for the editor, right, the wiki, and nothing else. And so I started doing that, and then I started thinking, okay, wait, what if this whole wiki page was a YDoc, right? Because like, why not? So I did that, and then I'm like, wait, what if an entire LegendKeeper project was a YDoc, right? And so then I did that, right? And so I tried that first, right? Where everything was in one huge YDoc, and that worked really, really well for small projects, right? And it was incredibly simple. I was able to take the providers that you created, right? YIndexedDB and YWebSocket, and immediately apply that and build, the local data model around that. But of course, as soon as I started thinking like, okay, let's take my most prolific power user, right? Make a project that looks a lot like their project and try to use it. And of course, at, essentially 10,000 documents, trying to keep that in one Y document, it did actually work, but it just took a very long time to parse, especially after like days and days of edits. And so that's when I started exploring subdocuments. I'm like, okay, every wiki page, right, is a subdocument now, and that was a huge improvement, at the cost of some complexity, right? Because I think everything in one Y document is like elegantly simple, whereas a bunch of subdocuments, you kind of have to do a lot more management, especially because, for example, YIndexedDB by default uses one database per document. And then why WebSocket uses one WebSocket connection per document, right? And so kind of the first order of business was making it so both of those could multiplex single documents into one cohesive, either database or WebSocket connection. Because what I found was I immediately was like, okay, how many documents can I have using YIndexedDB like as is? And I got to like 16,000 before Chrome was like, you can't do this. This is not allowed. You're not allowed to use IndexedDB anymore. I had to like completely shut Chrome down before it would like on any website. Like IndexedDB stopped working on every website.
Wait,
It was like,
I didn't know that. So you can't have more than 16,000 documents?
I don't know if that's the hard limit. That's just like where things started breaking down for me.
Oh, interesting. I didn't know that. That's good to know.
Yeah, and so IndexedDB itself just would not open on any website until I just closed Chrome down all the way. Right now I'm on Mac, so like closing things down all the way can sometimes, take some extra clicks. And then I'm like, okay, I need to put this all in one IDB database, right? Because IndexedDB is it's special. It's really good for the most part, I would say. The API, the default, the vanilla API is pretty bad. But if you use something like your YIndexedDB wrapper, or we eventually migrated to something a little more heavyweight, which was Dexy, which is a fantastic library. Using IndexedDB becomes a lot more pleasant. And so we essentially built a Dexy provider that keeps all the updates in one big one big updates table, and that works great. And that can 50, 100, 200,000 updates, and that works fine, especially if you're like regularly like compacting them using like the merge updates function.
Right. Hey, so somebody just asked if you have a link for that.
The Dexy provider. So no, mainly because it's really wrapped up in a bunch of LegendKeeper specific code. It's not like appropriate for open source. But that's one thing I was thinking about doing, like when I had some downtime, is kind of taking the idea, because it was at its core, it's like pretty straightforward. You essentially go through YIndexedDB, and instead of creating a new database, right, you're just creating like the appropriate key and inserting it. But yeah, I would love to create like a YDexy provider. I think that would be really cool.
Yeah. Also, like with that knowledge, I think that's a good critique point, not to create one database per document. That really doesn't make sense. I think it should support multiple documents, and after that, it should be fine, right?
Yeah, like if you're gonna create like 50 subdocuments, like that's fine. Like if you go into the developer tools of like Chrome or Firefox or whatever, you'll see a bunch of databases, and it won't be like pretty or whatever, but it'll totally work.
Yeah. But yeah, I guess you're right. Right? You created this whole infrastructure that communicates how to synchronize many documents with the server. Also puts that in a Dexy, IndexedDB database, and then you need custom features for enabling your search functionality, right?
Exactly. And so honestly, with better software engineering practices on my part, it would be easier to like extricate. But what ends up happening is like, okay, there's this pipeline of like side effects, right? And inevitably, like, especially the first time around when you're implementing something, the side effects kind of get mistaken for primary effects, and they end up in places where they shouldn't be. And so, yeah, like you put something in one of the that kind of transitions into our custom protocols. A big thing about the Dexy provider we created is it has a lot of knowledge about our protocol, because we got rid of the mutual sync step 1, which is kind of dangerous, right? It's and so in a Dexy transaction, we have the thing that also like marks a document to note that it needs to be synced, but probably getting a little ahead of myself there. And then yeah, so we took we created the Dexy provider, right? That puts all the updates in one table. But then we also took why WebSocket, and there I actually made a bunch of posts. Again, sorry, this is another one that I don't have like a nice clean library for, but I do describe the implementation in detail on the YJS discussion forum, where multiple WebSocket connections for thousands and thousands of documents wasn't going to fly, right? And so we extended the YJS sync protocol, right, the WebSocket sync protocol, to basically you append a subdocument ID to the front of the message. And so when the server receives a subdocument sync message, it knows that the first value is going to be a unique ID. It strips that unique ID off, puts you in the right context, and then just continues processing the message using the vanilla sync protocol. And so what that allows you to do is take essentially as many subdocuments as you want and sync them over the same WebSocket connection. And so those two things really start to unlock like the high scale like YJS architecture.
Right. Yeah, I will link to that discussion board. So now we know like there's a special sync protocol which basically asks for all the dirty documents, the documents that have been modified locally, and then it asks the remote server somehow to get the documents that have been updated since, and then you perform a normal sync step, right, for each document, which should be as problematic because usually even if you synchronize after a week, only like 50, 100 documents have been modified. You don't have to synchronize 10,000 documents anymore. So that's a lot better. And in practice, it should probably work fine. So
ultimately, it came down to, we developed kind of 3 new protocols for like a high scale, a data intensive YJS app. And that was, I call them OneSync, MiniSync, and AllSync, right? OneSync is basically the Y protocols. You send sync step 1, you get sync step 2. They send sync step 1, you get sync step 2. That kind of thing, right? With the addition of sync step 0 is what I called it, where you send sync step 0 to request that the peer sends you a sync step 1, like. So if you know something changed, but they don't, you send a sync step 0. From there, that moves on to the mini sync, where whenever the user, and this is kind of what enables offline, whenever the user changes one of these subdocuments offline, we keep a record of it in our database. And then as soon as we are connected by a WebSocket, which could be instantly, right? But let's say we're offline, as soon as we connect, we iterate through all of the dirty documents and send a sync step 0 for all of those and initiate this like bulk sync progress. We initially just used a bunch of OneSyncs in a row, but even that incurred like a pretty high like round trip cost, where even if you change 50 documents, like doing 50, double round trips kind of started to take a while. So what we did was you say, okay, I've got 50 documents. I'm going to encode that in the protocol. I say, here comes a mini sync. It's got 50 documents. Here's all their IDs, right? And so then the server says, okay, I'm going to send, here's 50 sync step 1s. And then the client responds with 50 sync step 2s. And so what you get is you're sending a lot bigger messages, but you save a ton on the round trips.
Right.
And then finally,
this is probably super complex for most listeners, right? This is not everything that this is about, like not just this description of the protocol, which has been described in the discussion board. It is fairly hard to implement, I think. You spent some time with it. I think you proved that it can be done efficiently. Also, like making this whole thing offline ready, like for a real application, for something that could compete with Notion or something, right? Something that syncs super efficiently. So now we have an offline ready app because all the documents are offline and we synchronize efficiently. And you want to provide offline functionality, right? You don't want to ask the server for search information of something. So you want to do all of this locally. How did you make search functionality, for example, work offline?
Yeah, so that's a great question. So first off, I think one of the key points here, which I'll use to kind of segue into search, is once you have all these sub documents, how do you find them, right? How do you know which ones exist and which ones don't? So if you think about it from like a wiki application, right? A wiki has a big directory where you see a list of all your articles and you can navigate to them, right? Where does that live? And so that's a big challenge. My first instinct was to create a subdocument called like a directory subdocument, which just had a mapping of domain model IDs to like the location of the YDoc. And then we use that to like load that YDoc. But I ran into a problem, which is, again, just pure scale, right? Where Y maps and Y arrays are incredibly performant, I think, up to a certain point, right? And so what I was finding is I was cramming tons and tons of IDs and metadata into a big YDoc, and the parsing time would go up, right? And because this was a kind of first render critical data fetch, we had to wait, right, to show the directory until we've parsed this YDoc. And so with these mega projects, it would take 5-10 seconds. We alleviated a little bit of that by moving it to a web worker, so you could at least get kind of a pleasant loading experience. But still, we found like every refresh waiting 5 to 10 seconds was just, it wasn't going to work. So I was like, okay, what if I used the provider pattern, this observable provider pattern, but for stuff that isn't like manipulating the Y documents, right? It's purely like domain model side effects. So I'm like, okay, let's say I create these subdocuments for my wiki, right? I'm going to attach like a metadata provider that just like watches the YDocs that I have loaded into memory, right? And indexes their content in a different place that it isn't a YJS related. And so this is why our DEXI provider is so kind of intertwined with a bunch of other stuff, because it's manipulating a bunch of other tables where we index the name, the tags, who their parent is in the hierarchy, what their position is. All of this goes into a secondary lookup table that we then use to like build the local directory. And so the advantage of this is, we don't have to wait for any like large document parsing. And again, it works offline. The disadvantage is increased complexity, right? You're essentially managing what is a secondary store, but you're treating it a lot like the primary source of data, because for a lot of the stuff in the UI, it is. And so when and if those get out of sync, it becomes very challenging. So with that in mind, yeah, so basically using the provider pattern for domain level side effects. And so if you extend that out, you're like, okay, so I index my metadata, then, okay, well, what else can we do that with, right? And so a local search index, I think, is kind of the next step. And so again, any YJS document loaded in memory, or if we receive a message remotely from the server, we immediately load that into memory and attach listeners to it. So using this idea, you can take something like Fuse.js or Elastic Lunar or Flex Search, like any browser-based search index, and have like a search provider that gets attached to your live Y documents that are listening for changes and then indexing those, and then also persisting the search index to somewhere in persistent storage as well, and it's then reloaded when the site comes back online or is refreshed or whatever.
Which one did you use?
So we ended up going with Flex Search. I definitely recommend checking Flex Search out. It's pretty cool. From what I can tell, it is like by far the fastest. But I will say it's like very troublesome to use. A lot of the features as described in the documentation like don't actually work the way they're described, which I got to a couple points where I was ready to give up. And then at some point I just like forked the whole thing and was like, I just went through the code because I knew I had this feeling like it was so close to what I needed. So I ended up just forking it and creating essentially a kind of a more LegendKeeper specific flex search to kind of optimize some of the common routes I was taking through it. But I think there's some good news in that the maintainer of flex search just came alive like recently. And he is, I think, about to release like a new version, or just did, that hopefully improves upon some of the shortcomings of it.
Right. I think it's a super interesting field. I'm sorry, I hear myself really loudly. Now it's better. Now it's completely gone. I'm not sure what happened. I think search engines for the browser, that's super cool. That will enable us to build real offline applications that really work offline. I think that was a missing part. And I honestly didn't know that there are search indexes for offline use. It's super cool.
And you can do some cool stuff. Hopefully this, this is a demo, so it'll probably mess up. But so we also use it for backlinks, like automatic backlinks. So let's say I go over here. Let's like random. Oh wow, all these images. Let's say I'm going Citadel. So I've changed the Y document, right? Immediately that's set off a pipeline to update this in the search index. Hopefully, cross your fingers. Then I go here, and now I get a kind of a semantic backlink functionality where, because I added this mentioned in property, it uses the search index to say like, oh, hey, by the way, like this article mentions this article. And nice. it can do like implicit or explicit.
And the search is super fast, right?
Yeah, because again, everything is, so when you first open a LegendKeeper project, and if you've never opened it before, it does, instead of doing any of the sync stuff, it just says, hey server, give me just a giant binary blob of everything you have on this project as quickly as you possibly can. And it's all, in the end, it's all text, right? And so the YJS binary format has about a 50% additional overhead. And so again, it ends up being crazy fast for even like pretty big projects. I would say right now our largest project to sync from 0 probably takes like 30 seconds, which is a lot, but like those users know they're power users. So they're like totally fine with it. And again, once you do that once, unless you're clearing your cache every time you close your browser or like deleting the local database, you don't have to do it again, which is pretty exciting.
Yeah, it's super cool. So now you built an offline app, like really offline first, which enables collaborative editing through a server that you maintain. In case of like your service shutting down, users can still open this. I see it's an app, right? It's a real Electron app or something.
So this, I'm actually just doing, this is a Chrome app.
Oh,
yeah, kind of the same idea.
It's a web app, so you hit the install button, right?
Yeah, and I'll be releasing Electron apps pretty soon. There's just a few like little things. With Electron, like for the most part, if you have an offline capable web app, you can just sort of wrap it up and get like a passable like desktop app. But there are a few like security things and like some cross-site scripting kind of stuff you need to watch out for, just to make sure it's secure. Since Electron does give you access to the node functions, that can be dangerous if you don't really like sanitize and like make sure you're denying access to those APIs.
Right, that makes sense. But yeah, it's like offline. What did I want to ask here? So you take away a lot of the complexity from the server and instead put that into the client, right?
Yes.
What does that mean for the server?
Yeah, so that's a big trade-off, right? And this is actually where my my history with mobile development kind of came in handy, because this is kind of more along the way mobile apps work. Because by default, and I think the web dev world, I think we can learn a lot from mobile applications, because mobile applications generally, the good ones, assume that your connection is unstable at all times. That at any point in time, you could go through a tunnel, your stuff goes away, right? That sort of thing. I don't know where I was going with that. Oh, right. And so you move a ton of the complexity and a lot of the authority too from the server to the client. And so it becomes important, one, to like scope, pretty heavily scope your users to like their projects, right? So giving someone access to the WebSocket connection that can mutate a YDoc is not something to be taken lightly, right? And so a user can only, of course, manipulate their own private project. We do have, I'm actually working on this right now. We do have plans to be able to expose your project publicly to the world, but it will use a completely different system, right? It doesn't really need YJS to work that way. We're going to essentially build another one of those big secondary indexes, but do it on the server so that we can create static pages from it.
Right.
So a ton of the functionality comes off of the server, and the server becomes this very data agnostic kind of solution. And obviously, like, depending on your application, it will have some different, specific functionality. But at the end of the day, it becomes a system that says, give me YJS updates, and I will give you YJS updates in return. And that's like almost all it does. And of course, it also runs, authorization, right? It'll, let's say you do like your initial WebSocket handshake, and the user says, hey, this is me, this is my ID, this is my token. And the server says, what projects do you have access to? Are you even allowed to connect to me right now? That sort of thing. And then it, either, upgrades the connection or kicks them off, or, whatever.
Yeah, what I really like about this mental model of taking away power from the server and complexity is that you can easily exchange it. Like, let's say some user wants to start quickly, they're going to use some service that somebody else maintains. Maybe they built their YJS backend on top of Firebase, which is super expensive, but you get started fast and it works generally well. And then they can switch to something more performant. And you built your own stuff, like your own scaling solution and everything. It's super cool. But in case you ever want to switch, right, you want to pay somebody else to host some solution, in case there's better solution built in Rust, for example, that works like 10 times faster, you can switch to that solution because you're independent. The server is really dumb, and you don't need to re-implement a lot of stuff.
And that does have like a lot of caveats too. Like I've discovered firsthand how like dangerous that can be too. I've had a couple scenarios, because you have all these sync protocols, right, that are trying to keep documents in sync. You write, a bug on your development copy that, mangles an update or puts stuff in an invalid state. If you're connected to a server, that's going to get shot up there, right? And if the server doesn't do any validation, which if it's a very dumb server, it probably shouldn't be doing that much validation. And then it sends all that stuff to everyone listening. And so I had a situation where this was in testing, right? Like we had like months of testing before we released this to production. But I had a cohort of like 50 people like helping me test stuff early. And I remember I did something, and immediately like 5 of those people were like, hey, the shared project we're in, everything just went blank. I'm like, oh no. Because I had somehow sent just a garbage update that was just meaningless, weird manipulation of the YDoc. And not only was that sent, it was like persisted and like super sticky, right? Because it works offline and it's multi-master replication. And so anytime someone would like come back online, everyone else's stuff would break again. Like it was pretty nasty. So being aware, and there are hundreds of those little edge cases that you got to watch out for, and like, try to build mitigation for it. That's where lots of I've always been into test-driven development for the most part, but like introducing YJS like really like it became a necessity. Like there is a certain kind of danger when you give the client so much authority, and not so much from malicious actors, right? Because like if malicious actors are only confined to like their projects, like they don't care. They're just trying to break stuff. So that's no fun. But it's, bugs, right? Which inevitably will happen, whether you're a solo developer or a team of folks, like bugs are going to happen and you got to have a plan. Another cool thing about the server being dumb is it makes feature development like trivially, like I don't want to call it easy, but like so much easier than it was before. You don't have to have like a full stack mindset where you're like, okay, I'm going to add this feature. I need this database table, and I need this controller on the server, and I need this model on the server, and these routes, and then you go to the client, and then you build all the view layer stuff for it. When you have a application built off of something like YJS, where the client has a nice level of autonomy, you just add a feature to the client, and you're done, and it'll just work.
Right. I think that is a good lesson to take, that this introduces new complexities, also new opportunities, right? It's a completely new way to develop applications. Somebody just, exactly, it's sort of a new kind of app development. Yeah.
Yeah, it's a new paradigm. That's like, it's funny because it's kind of a throwback to like desktop applications, because like, I think we've gotten used to with web apps, you can force the user to use your latest version, right? And use the latest data, or you can go to the source of truth in your database and like fix the problem or whatever. But now you have to think, okay, the version of the data and the code that the user has is like just as correct, which can be tough, right? And so stuff like migrations, right? Like, let's say I want to update my search index. How do I make that happen? Or, update the tables, or I want to change the domain model from one of the hardest things was I realized that there was a Y map that I wanted to be a Y array, right? And this was before we released to production, but I was like, okay, I'm going to pretend like I've released this to production already. And I'm going to like do an exercise, right? And make it so I can't just go in and like delete the database and start over. I have to figure out how to enable this feature, right? And perform this migration silently, like without breaking everything. And that was like, if anyone who's building a YJS application, you should practice this. It's a really an important thing to do, because what you don't want to get into a situation where you launch to production and you realize you don't have a plan for a major data model change. Right. Yeah, exactly. Like at the very least, versioning, or like, sorry, that probably won't make sense in the recording. Someone put a chat message. They said data model versioning or something, so versioning your data, having a migration strategy for all of your like secondary data stores, right? So if you have an index of metadata, if you've got a search index, they all need a plan that they can, at the very least, delete and rebuild themselves if they detect like something has gone wrong or something has changed. Yeah, this is another important lesson, right? Although we don't have versions and schemas anymore, we still need something like a schema, right? Even if it's just in our head, maybe it's just the TypeScript annotations that we version with some package. Something that I learned in Jupyter project is it might be really helpful to think beforehand what your application state should look like. For example, in the case of Jupyter Lab, for example, or Jupyter Notebooks, you have a list of cells, and each cell has output, and a cell can be either a raw cell or a code cell or a markdown cell. So you have like a specification, you have a JSON schema actually for that, how the metadata looks like. So you can build an API around it. So what we did, we built an abstract model around this, implemented it using YJS, and then defined, okay, this is version 1. And if we ever want to upgrade it,
we need to hide the complexity of using the YJS types below the model, right?
Yeah.
Even if we want to rename a field, we can't just rename a field. That's not possible. But from the API perspective, we can just rename a method. That's not a problem. And it can still be compatible with old versions. So maybe that is one solution. Another solution is, of course, as you said, simply reload the complete state, like make a JSON copy out of it, migrate it to a new YJS state, and then insert it again in the YJS document. That also works, right?
Yeah.
And it's a completely fair solution. The only problem is that every few months or years or whatever, in your application, when you want to upgrade to a new version, you need to tell the client, okay, this is the new version and everything else is now broken. The problem is with an offline application, this might be kind of complex because, like in your case, maybe somebody has been working offline and on some island and then joins back to Europe, and then the server says, hey, I'm sorry, I'm going to delete all your stuff because we have a new version of the schema.
Yeah.
So that doesn't work. But yeah, some things to think about. Maybe there are migration steps that can be performed while offline. Maybe you can just have copies of different versions, like how Evernote does it, right? You don't get a sync conflict. You just get like the same node twice, but with a note, hey, we couldn't sync, so you have your content now twice. That's a solution. But yeah. In terms of performance, and maybe this is the last thing that I want to ask, like how well does your server scale? How many users do you have? You showed me some impressive charts, like in terms of memory usage and all that stuff. Are you willing to share that?
Yeah, absolutely. Let me
cool.
Overall, scaling has been a dream. It's so previously the core LegendKeeper's core, right? The user system and the auth system is all still using a more traditional. It's funny to call GraphQL a more traditional approach, but that's how like out there like building an app with YJS is. It's like the future. So I when I first built LegendKeeper, I was also like, oh, I want to learn GraphQL. So it was all built on GraphQL. And I can rant all day about GraphQL. I won't waste your time with that. It's GraphQL is fine. I think it's a little overhyped personally, but I think for specific cases it works pretty well. I think for ours it wasn't like the best fit. But regardless, all of the previous feature implementations were through GraphQL, right? Which have the same kind of overhead as HTTP, right? Because it's using essentially post requests for everything. So what we found is, of course, you have a live WebSocket connection and you're sending these very tiny binary encoded updates, which are way smaller than JSON, right? And so you end up with a way better performance profile. And so we launched the YJS version of our app on May 25th. And I scaled up everything just because I knew the migration would be kind of taxing, and it was. But then after the first few days, as people were starting to finish their migrations and taper off, I found that we are like totally over provisioned now. We're spending. I'm one of these nights, like late one night, I'm just gonna like scale down all of the the nodes in our Kubernetes cluster, and then just like selectively scale up until everything fits again, just to like get our costs down, right? Because the when you go from the average request taking 50 milliseconds to the average request taking 1 millisecond minus round trip time, that frees up so much more server time to do stuff on. And so we use Node.js as our backend, and we just have all this wiggle room now, which is fantastic. Which is why we need to scale down a bit. Let's see. So one of the things I found, so we use New Relic for tracking transactions, right? And I actually had to between, Kevin, we had a call last week. Between now and then, I actually had to scale down. I had to put in I had to wrap our APM library with a sampling code because YJS is so chatty that like we were creating like too many events. And so the numbers that you see won't look quite as impressive because I've scaled them down by a factor of 20 to save money. But let's see. Just make sure I'm not showing anything secret on these dashboards. That should be fine. Yeah, so what we found is, and don't mind, we're over our free tier limit, so I gotta put in my credit card at some point. You find that overall, like these are, so transactions now, right? The server is very dumb, so a transaction is a YJS update back and forth. It's either give me the state of the YDoc, or it's hey, I made this change to the YDoc. And so as you can see, like almost everything is 1 millisecond or less. You have a few spikes here, but the spikes are like 70 milliseconds. Like, ooh, like what are we gonna do? Like
the spikes are probably some users syncing a lot of documents. Is that
exactly? Yeah.
Okay. But yeah,
so
70 sounds good.
Because we the bulk sync, that's also considered like one transaction, right? And then I can show you our estimated actual throughput, because this is like, for some reason, New Relic doesn't allow you to do sampling, which I think is a little strange. So we were just creating, gigabytes upon gigabytes of logs, just because, that's YJS. It's very chatty, right? So if we go to, let's see, the dashboard, how do I get there? You can see our actual throughput here. I wrote like a custom query to kind of estimate the true throughput. It's 9,000 requests per minute, which is like, it's not bad. Like that's pretty nice. And so again, the average response time is still a couple of milliseconds. And yeah.
And that's really impressive, because like for each update that you receive, you need to put it into Redis, I think. You use Redis, right?
Yeah.
Yeah. So you send it to Redis, and then you propagate it to all the other users. So there's some bookkeeping going on. And 1 millisecond is like, for a Node.js application, it's fantastic. That's because,
and of course that doesn't include the user. Like the user request time is whatever their round trip time to the server is plus this, right?
Yep.
But again, we went from 50 to 100 milliseconds to 1 millisecond, which is amazing.
But it made me really happy that you are able to scale down. So this is good.
Yeah. So ultimately, YJS is going to save us money, which is awesome.
Nice. All right, that is what I wanted to hear. Awesome. Maybe we leave it at that. Thanks so much, Braden, for doing this. For everyone listening till here, check out LegendKeeper. It's super awesome. Like seriously, I'm kind of sad that it's not my regular note-taking app, because it's super cool. It's like so fast, and it's offline with offline search, and there's nothing out there on the market that does that, I think.
Yeah, if you are a game master or a novel writer, or we've actually got game studios that come and like plan out their like open world games like in LegendKeeper first, and then they go build it. So like any kind of creative project where you are like building a fictional setting, like that's what LegendKeeper's for. And my goal was to like make that activity fun, right? And so it's just fun to like just sit down and just like ideate and write and be like, oh, like who lives on this planet, and like what are their customs, and then you end up writing an article about like these people's customs, and you're like, okay, now I should probably like write a story or something too. And you just get so like drawn into like the act of world building. It's a lot of fun.
This is so cool. Yeah, thanks so much. Jeremy, do you have any questions? Otherwise, let's give him like 10 more seconds, because at the end of like the interviews, I would like to do some open questions. But some people already left the room, and I think Jeremy is unavailable. Okay, he has to run. Thanks so much. I will link some resources in the video, and yeah, see you, Braden.